Okay, so classical probability, you can use math to figure this out, no experiment required. That's an example of that would be like rolling a dice. Um, you can tell that there's a 1 in 6 chance for every single thing. All of this up here is all classical probability. We can figure it out just using math. We don't have to do an experiment. Empirical is an experiment. You've got data, either from the past or currently that you're looking at. So you could say like, hey, you know, from experience, we know that 42% of people in this town have a dog. What are the chances that the person at the next house has a dog? And that would be 42% because you're looking at past data. This is also stuff like presidential polls. Trying to figure out who the next president would be, that kind of thing. Subjective is an educated guess. This is like predicting the weather. There's definitely math and science that goes into predicting the weather, but ultimately, when they say there's a 40% chance of rain, they're making a very, very educated guess. They're not going to say, we've looked at all of the February 9ths in the past, and this is how many of them were rainy, so that's what it means right now. Like, they can look at weather patterns and so on. Law of large numbers. As an experiment is repeated over and over again, the empirical probability of an event approaches the theoretical or actual probability of the event. That means that as you do a experiment over and over and over and over again, it is more likely that you would get exactly what you would expect using a calculator. So for example, like let's say that we were rolling a dice and we wanted to know whether we could get a 6 or not. Let's see if my calculator, this one can do it. Probability, we can. 1, 6, 1. Okay, so if I get a random integer, I got a 4. Let's say I was trying to get a 3. Okay, so I'm trying to get a 3, and so far I've done one experiment, and my one experiment has shown that I've got a 0 chance of getting a 3 because I didn't get one. So then let's say that instead I up that number. So, oops. Math, probability, random integer, 1, 6. Let's say that I do this trial 10 times now. So I'm going to do it 10 times. And this time I got 1, 3. So we all know that the probability of getting a 3 is 1 in 6. Which is a 0.17 chance of happening. And so then if I do 10 trials, I got 1, 3 in my just experiment, and that is a 0.1%. So here you see I went from like a 0% chance to a 0.1% chance just by upping it to 10 trials, and I'm trying to get to 17. So if I did 100 trials, I'd be a lot closer to that 17%. Than anything else. Yeah. So if I did 100 trials, which I'm not going to do because I don't want to waste your time, but if I was there, maybe we'd do 100 trials and see that it was pretty dang close to 17. Range of probabilities. The lowest a probability can be is 0. That's 0%. And the highest a probability can be is 1 or 100%. So a probability is either a decimal between 0 and 1, or a percentage between 0 and 100, or you could have a fraction as long as that fraction isn't higher than 1. Complement of an event is figuring out the opposite. Probability and subtracting from 1. So sometimes it's easier to figure out the opposite of a probability than figuring out the actual probability. So it says, what's the probability of not getting two numbers that add up to 7 when rolling 2 dice? Well, first of all, if I'm rolling 2 dice, that's 6 times 6 possibilities. So we've got 36 possibilities. See, getting two numbers that add up, not getting two numbers that add up to 7. So I could start listing all the numbers that don't add up to 7. I could say like 1, 1 doesn't add up to 7, 1, 2 doesn't add up to 7, and so on. But it's a lot easier to think about the ones that do add up to 7. So I could get 1 on the first die and a 6 on the second, or a 6 on the first die and a 1 on the second. I could get a 2, 3, or a 3, 2. Although that's 5. I could get, let's see, what that would be, a 2, 4. Yikes. Already making mistakes. I must be tired. A 2, 4 and a 4, 2. Or you could get, and these don't, we're adding up to 7. My goodness, what's wrong with me? You better be laughing at me right now. Okay. 1, 6, 6, 1, 2, 5, 5, 2. A 4, 3, or a 3, 4. That looks like a total of 7 choices, 6 choices. Woof. 1, 2, 3, 4, 5, 6 choices. So there are 6 ones that add up to 7 out of 36. So if I subtract from 1, that would be 30 possibilities that don't add up to 7. Man, I've been struggling today. Which would be what? Divide by 6, so we'd end up with 5/6 possibility of getting something that doesn't add up to 7. Just gonna look at that one. We're covering a lot of information very, very fast here. Okay. So next thing we're going to do is talk about conditional probability. So this is section 3.2 we're moving on to. Conditional probability is the probability of an event given that another event has already occurred. 2 hours? Who could tell? So what this means right here, it means that this is what you're trying to find, the probability